Hello, year 8. I am Marco Urey, your math teacher, and today we are going to work on significant figures, ratio, speed, rate, and scale. I hope you enjoy the video. This video is for you to be prepared for these topics. I know these topics were a little bit um, complicated for some of you. Some of you also you got problems maybe remembering some rules. And this video is for you to study so you can just remember um, what things we are supposed to do all the process. Well, I hope you enjoy. So this is the quiz. I added one exercise related to speed that you had last class. And in the exam, needless to say, I will be based on this quiz as well. I'm going to take some of exercises from here. So let's start. So for this exercise, you'll see that you have these shapes, right? The task is to find the real length of the car. Well, if you don't remember, in the exam you are supposed to have a ruler because here we are going to work with scales. And it's really important to mention that if we are going to work with scales, we need to have a ruler because a ruler is going to help me out. So I know I am a computer, but I have my own tools here to work with a ruler. So let's begin. We have these two exercises. Sorry for this. I am going to put it in the board. Let's begin. Okay, so according to this exercise, we need to find the real length of the car. So we have the following information. The accurate scale drawing shows the car. Okay, this is the car. And it says that the car has a real height of 1.5 meters. Okay, so if we are talking about the height of the car, we have to know that the height of the car is going to be based on this. So this is going to be the height of the car. So what we are supposed to do? We are going to work on the scale. And as you remember, a scale has two parts. A scale has a part that is always the part that is on paper. So let me write it here, paper. And there is another part which is for real life. Sorry, this sometimes happens. This is going to be real life. Okay, so what I want you to notice is that we know that the car has a real height of 1.5 meters. So we are going to write in this part 1.5 meters. With that said, we know that this is 1.5 meters, but we don't know how much is that on paper. So what we are going to do? Well, as I told you, I have a ruler here. So let me take it out. As you can see, we have a ruler. If we measure with a ruler here, we can notice that the height of the car, according to the ruler, is going to be let's see, 3 point. Let me zoom in. Here we start from 0, and we can notice that the height of the car is going to be 3.56789. So we can measure with the ruler that the height is going to be 3.9 centimeters. Okay, so you maybe were wondering if I am sure about this because I'm in a computer. If we go to Word, to the document, we can cut the image. So let me show you. And well, you are going to notice that, well, the picture here, it shows that we have a height of 3.05, which actually means that I am wrong. I mean, I am wrong from the board. The board is taking another measurement. So what I'm going to do is I'm going to adjust the image so we can have an accurate picture. So according to the document, we are supposed to have a height of 3 centimeters, 3.05. Okay. So let me adjust that. This is supposed to be 3.05. Let me make it a little bit bigger. Very good. Now we have it's a little bit more small like this. Okay, so if we measure the height of the car a little bit bigger, we are going to get the actual height, which is 3 point. Well, you can see that is 3 centimeters and a little bit more. So, well, thank you for your patience. Sometimes this happens in computers because I don't have the exam on paper. Well, actually, I don't have a ruler. Yeah, it sounds funny because I am the math teacher. Usually I have everything, but I forgot my ruler at class. So again, the actual height of the car, like if you have your quiz with you and you measure it, the actual size is going to be 3 centimeters. So let me erase this. And we are going to have again our height. This is the height, which is going to be 3 centimeters. 3 centimeter height. Okay, I hope that this part is clear. So 1.5 meters is what we have in real life, but 3 centimeters is what we measure on paper. Now, please pay attention to the task that it says that we need to find the length of the car. So we are looking of the how long is the car. So what we are real looking for is okay, how long. So if we move or maybe the line here, how long is the car, like how large it is. We're going to point a line here, another line here. We can do the line. This is going to be what we are looking for. So again, if we take the ruler, now we know that the ruler is precise. If we move the ruler, okay, like this, and we measure, you can see that we exactly have about 9 centimeters. So I would say that is 8.5, 8.9. But if you do 9 centimeters, we are going to do 9 centimeters, so we don't complicate with decimal numbers. So what you have to be aware of is that we are measuring on paper. The length of the car right now is on paper. So we know that, again, on paper, is going to be 9 centimeters. This is going to be on paper. Now, here comes the part where you have to be aware. Some of you already know this, some of you don't. What we are going to do is the rule of three. Rule of three. You use it a lot. I really like it because it's really useful. So we know the following thing. We know that we have two things. We have paper, and also we have real life. Okay. So we know that, for example, on paper, we have 3 centimeters, which means that in real life we have 1.5 meters. Now, when we measure with the ruler, once again, we found that on paper, we have a measurement of 9 centimeters. So we are going to look of what is going to be 9 centimeters in real life. Now, the rule of 3 is very simple and really useful to do. What we have to do is multiply, well, we have this thing, and the rule of 3 is very simple. We always have to multiply in diagonal and then divide with the other number. Maybe this is weird or like you don't understand the rule, but let's go step by step. We multiply in diagonal means that we are going to multiply the numbers that they are in diagonal, for example, these. But mister, can I multiply the other? No, because this is in diagonal. If we try to multiply this, we don't know what is this. We don't know. We are looking for this value. So to find that value, we are going to multiply the numbers that we have. So we are going to multiply these two in diagonal first. So again, this result, which I am calling x, is going to be the multiplication of 9 times 1.5. So we can write it here, 9 times 1.5. And then what it says, divide with the other number. What is the other number? The other number is this one. So we are going to divide it by 3. And again, you have calculator, we can do this, 9 times 1.5 over 3. So 9 over 2 as a decimal is going to be 4.5. So actually in the exam, the result was 4.5. And remember, we are talking about real life. Real life. In real life, we are talking in meters. So we have to write that the result is going to be on meters. Therefore, the result is going to be 4.5 meters. All right. With that said, let's continue. If we continue with the following exercise, with the next one, I will have to do a little bit more space. I'm going to move this here. We will continue with number 2. As you can see, number 2 has more marks, and it's for a good reason. So here it says that the accurate scale drawing shows a field. So this is a field, maybe a football, we don't know. Now it says that the field has a real length of 67.5 meters. So here is given that the field has a length of 67.5 meters. Okay, that is real life. So we can write it as real life is going to be 67.5 meters. And well, we are looking for the perimeter of the field. So what we are going to do? If we know that the length of the field is 67.5 meters on real life, we are going to take the ruler and we are going to measure the length as well. So if we measure length with a ruler, let's try to be as exact as possible like this. We will see that this is 8.123. Well, I would say is in this position here. This is going to be 8.3 centimeters long in paper. So we are going to write that 8.3 centimeters. So in the ruler, we are not going to need it here, at least for a moment. So this is going to be the scale, but there is a catch. We need to find the perimeter of the field, the perimeter. So what we can do, as we know, the perimeter is the length of all the sides. So we have this side, this other side, this other side, and this other side. We know that the length of the field is 8.3 centimeters. 8.3 centimeters. Also for this other side, 8.3 centimeters. But we don't know how much is this, right? So again, we are going to take the ruler. We are going to measure. Let's make the ruler smaller. We can make it like this. And we are going to measure how high is the field. We can move the ruler a little bit to adjust. We can see that, well, this is going to be starting from, well, let's put a little bit more up here. This is going to be 1 to 3 point. Write it here is 3.5, 3.67. 3.7. So we know that this is going to be 3.7 centimeters. So again, this is also going to be the same, 3.7 centimeters. Now we can get rid of the ruler for a moment. So again, these measurements are on paper. And according to the exercise, we are looking for the perimeter. So what we are going to do is look for the perimeter on paper. So here we will be looking for the perimeter. The perimeter, as you know, is the sum of all sides. So we are going to add all the sides. And remember, this is on paper. So we are going to add all the sides. So the perimeter is going to be 8.3 plus 8.3. Now let's add the other two sides, 3.7 plus 3.7. And again, we can have the calculator. 3.7. Well, let's do this correctly. It is going to be 8.3, 3.7. Here we have plus 3.7 again. And the result is going to be 24. So this is going to be 24 centimeters. But again, this is going to be on paper. So we are going to take this, the rule of 3. All right. I'm going to copy and paste. I don't know why I changed the color. Okay. So once again, what we are going to have in this situation is that we have the paper and the real life. On paper, what do we know? On paper, we know that 8.3 centimeters. On real life means 67.5 meters. Now, we are looking for the perimeter of the field on real life. We know the perimeter of the field, but on paper, please remember and keep in mind that this is on paper. So what we are going to do is take the measurement on paper, which is 24 centimeters. It's very important to keep it in the same side of paper. And again, this side, this part that we don't know, we are going to call it X. Now, the value of this thing that we don't know is going to be, again, the multiplication cross, 24 times 67.5 over 8.3. So if we multiply that, I don't know how much it's going to be. Here we have fraction 24 times 67.5 over 8.3. Well, we have 195 195.18. 195.18. Please keep in mind that this is real life, so this is going to be meters. And just like that, we had the answer. So my recommendation, have a ruler, and please remember that we need to always compare what we have on paper compared to what is on real life. Always, that is, I would say, this is the key of this part. Okay, let's continue with the exercises. Here, this is a very short, in my opinion, the easiest one. It says, from the previous scales, write the scale in the form 1 to R. Well, this is more technical, but we need to remember, because it's really important, that this 1 to R form to write it is the standard way to write scales. So, for example, we had two scales before, which it was this one. Let me copy and paste. Let's copy, put it here. Okay. And the other one, which it was this one. Well, let me copy naturally with the same word application. Yeah. So once again, if we write this, like a formal way to write it is 3 centimeters to 1.5 meters. So this is the scale, like how it's written. But again, let me fix this. This is going to be 8.3. And this is 67.5. Okay, so as you can see, these are the scales from the previous exercises. And we need to write it in the form of 1 to R. Again, this is one of the easiest parts, but has a tricky. It has a trick. So before doing this, and I will write it up here, we need to make sure that let me make this bigger. All measurements are in the same units. What I mean that they have to be in the same units. Here we have centimeters and we have meters. They are not in the same units. So what we are going to do? We are going to convert one of these in the other unit. Now, in my opinion, it's easier to convert meters because we know that 1 meter is the same as 100 centimeters. So that's what we are going to do. All the meters here, which is 1.5, are 67.5. We are going to convert them into meters. So here I'm going to write it just for you not to forget. Convert the meters into centimeters. That's the key here. So let's do that. If we multiply, well, if we write 3 centimeters here, and we convert the meters here, we only have to multiply 1.5 meters times 100. Always when you want to convert meter to centimeter, you only have to multiply by 100. That's just the only thing we need to do. 150 centimeters is going to be the answer in this part. 150 centimeters. Once they are in the same unit, there is no need to write this anymore. So this can, let's say, can cancel out. It's a way to see it. So this is going to be 3 to 150. And this is really important because it doesn't matter if it's centimeters, meters, inches, this measurement, because they are the same unit, it doesn't matter what unit do we use. If this is meters, this is going to be meters too. If this is inches, this is going to be inches too, etc., etc. But we didn't have this form yet, 1 to R. As you can see, in the left side, we need a 1. Here, I don't have a 1. So what we are going to do is very simple. We are going to divide this number 3 by itself. So 3, we are going to divide it by 3, which is going to give me 1. Now, this same number, we are going to use it to divide the other. 150 divided by 3 is going to give me the other result, which is 50. Oh, now this is going to be the correct answer. This is in the form 1, 2R, and we finish. Okay, if you didn't understand, we can go for the next one. Now that we have this, again, we convert this into centimeters, sorry. So we will have 8.3 centimeters. We convert this into meters. We only have to multiply by 100. With a calculator, it's easy. 67.5 times 100. 6,750 centimeters. And again, we use this same number to divide it by itself. So we divide by 8.3. This one as well divided by 8.3. So this is going to be 1. And well, for the other, I'm not sure. We have 6,750 divided by 8.3. Now, maybe it's decimal, there is no problem with that. So now what do we have? 813.25. 813.25. This is the way that we are supposed to write it. That will be the final answer for this. And well, we also have for this. Okay, let's go by the next one. Sorry, this is another thing. Here we are going to enter to significant figures. In this section, what we are going to do is, well, please, first we have to read carefully. It says, without using calculator, estimate each of these expressions by rounding, and this is the important part where it says each number. So as you can see, we have a lot of numbers here. Please give me a moment. I am receiving a call from my phone. I'm just going to. All right. Sorry for the interruption. Let's continue. We are here in number 4. So here without using calculator, we have to estimate this for each number. Now listen to this part. It says by rounding each number to one significant figure. So in this part, if we have to remember the rules, that's why I have here the presentation open. Please remember the rules for significant numbers. So zeros in the front are not significant. Numbers different from 0 are significant. And well, we have non-zero digits in a decimal place. After like the decimal place, they are significant. Please remember, for example, here we have 3 significant numbers, 2 significant numbers. All numbers that they are not 0 are significant. The zeros between as well, they are significant. Leading zeros are not significant, like these ones. But also we have to make sure that, that the zeros, when they are not decimal, they are not significant as well. So for example, here I have 83,000. It's only 2 significant figures. So it's just these only 2. But the moment you put a decimal point, this becomes significant. Well, in this exercise, it's a little bit different, but it's important to remember the meaning of this. If we want to round each number, because it says rounding each number to one significant figure, it means that this number 73 73. We have to round it to one significant figure. So if we round it, we are only going to stay with the first digit, 7. And we have 3. Well, if we remember rounding, if we have 3, we have to round to 0. So as you can see, this number has been rounded to one significant figure. It's only one significant figure. This is not significant because, again, we check the rules. Any zero that is after a non-zero number is significant only if there is a decimal number. So for example, here there is no decimal number. That's why it's only two significant figures. And here happens the same. Now, in this situation, for the next number, we have the same thing. But instead of rounding down, because the number that we have in the right is 9, we are going to round up. So, since this is going to be 9, we have to round up to 30. Well, sorry, 40. So this is going to be 40. As you can see, both numbers, they have been rounded to only one significant figure. We can just do the multiplication. 7 times 40, it's 70 times 40. Well, it's 7 times 40 is 28. We added 2 zeros. And well, that's it. We finish. Let's go by the next one. Yes, in fact, this is the answer we just finished. Now, let's go by the next one. In here, this is going to happen again. We have to round to only one significant figure, which means that we are going to get rid of these two. Since this is 9, we have to round up to 400. The same here, we have to get rid of this. We got to round down, well, 21, we round to 20. Here we have division in the middle. And then we have 12. That if we round it, we have 2, it's going to be 0, so it's going to be 10. 400 divided by 20, well, we can divide 40 times 2. Well, 40 divided by 2 is going to be 20. 20 plus 10. And the final answer is going to be 30. Yep, with that we finished these exercises. They were pretty simple, but we have to remember these rules. Let's continue. Here we have to estimate each one of these values. So this was explained in class. This is going to work the same as before. We are going to round these numbers. So you can use your calculator, yeah, but it's not going to give you the estimated value. That's why it says estimate. Therefore, what we are supposed to do. When we have roots like this, we have to look for what root is going to be more close to this. For example, the square root of 100 is going to be 10, right? But the 100 and the 120 are not pretty close. So maybe if we try for 114, it's not exact. What if we go by 120? You will see that 120 is 10.9. So what is the trick here is that you have to remember all the square numbers. 1 square, 2 square, 3 square, 4 square, etc. If you remember this, you are going to be safe for this exercise. This is 1, this is going to be 4, this is going to be 9, 16. If we continue, we get 10 squared, which is 100, and 11 squared, which is 121. Now, this is going to be our estimated answer because this is pretty close to 121. Therefore, the estimated answer is going to be 11. So maybe if you take your calculator, you will realize that square root of 120, in fact, is pretty close to that answer, right? 10.95. But the correct process is to show that this 121 is very close to the real answer. Remember that the point of this topic is that to do the right estimation. Now, the same is going to happen here. We have a cubic root, right? We have cubic root. And for cubic roots, the same is going to happen. 1 cube, 2 cube, 3 cube, 4 cube, etc., etc. If we do 1 cube, it's going to be 1. 2 cube is going to be 8. If you're wondering why is it 8, it's because we are multiplying 2 times 2 times 2, 3 times. Or you also in your calculator, you can see it like this, 2 to the power of 3, 8, right? And the same is going to happen here. This is going to be 27. And this is going to be 64. Now, the same as before, we have to show that this is going to be the closest. If we do the cubic root of 64, it's going to give me 4. So this is the estimated answer. And if we check it with the calculator, oh, I close the calculator. Sorry for that. Open again. If we check with the calculator the cubic root of 60, you can see that is pretty close to the result of 4. 3.91 is very close to 4. And with that, we finish. Now, when we have to estimate again, for square roots, it's going to be the same logic. As you can see, if we continue for roots, if we go by 12 squared, it's going to be 144. So this is going to be a square root of 144. And since we are estimating, what we are going to do is estimate these values. We are not going to keep a decimal. We are going to round. In fact, this we can write it like 20 or 23, sorry. And this we can run it up to 10. So we are going to compare the answers. In this situation, this is going to be 12. And here we have 23 minus 10 is going to be 13. That if we multiply 12 times 13, 156 is going to be the estimated answer. Now, this is the correct process. This is what we are looking for. If we take the calculator and we try to write it, square root of 144 times 23.25 minus 9.63, you will see that the answer is 163.44. I know that this answer is a little bit far from the correct answer. I am aware of that, but this is not 144. This is 143. Well, again, it's not going to be that close to the real answer, 162. And 162. But again, it's only six units off. In my opinion, well, not in my opinion, the main thing for you to do is to estimate. So as long as you did the estimation from here, you will have the full score of the 2 marks. Well, let's continue. And here, this is one of the hard ones. A box of apple is divided in 2 bags, C and D. The ratio is 4:7. The number of apples in a bag is 36 more than the number on the bag C. Okay, so we have 2 bags, C. And we have the other ones, D. We know that the ratio here is 4:7. So we have 4 apples here and 7 apples here. Oh, well, that is a ratio for 7. And then it says that in this bag we have 36 more. So what I want you to notice, let's say that we make groups of the apples, okay, because here we have apples. Let's say we have 1 group, 2 groups, 3 groups, and 4 groups. Let's say that every group has an apple. And in the other one, we have 7 groups. So we have 1, 2, well, let's make this fast. Going to be 4. That's going to be 6. And if we copy one more, these are going to be 7 groups of apples. Do we know how many apples we have in every group? We don't know. That's what we are looking for. Now, we know that according to the exercise, we know that the number of the apples in the bag D is 36 more than the number of the bag in C. So we know that if we take away these groups, we have the same amount of apples, right? Because we have the same amount of groups. But if we add these, we know that these are 36 apples. We know that these are 36 apples. Why? Because if we take away the groups, they have the same amount, but if we add it, here it says that we have 36 more apples. So we know that every group here, like these 3 groups, in total they have 36 apples. So what we can say, every group has an amount X. Let's say this is X, 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 and X. Okay? X is the number of apples in every group. So we know that these 36 apples are in 3 groups. So we can say that 3x equals 36. Or you can just say, okay, if we divide this in 3 parts, that means that we have to divide 36 by 3. This is going to happen in this equation. So we know that every group has 12 apples. Now, this is not the final answer. It's only going to help me to find the total number of apples in the bags. We know that in the bag C, we have 4 groups of apples, but we know that every group has 12. So 4 times 12 is going to be 48 apples. And in the case of D, we know that we have 7 groups, so we have 7 times 12, which is 72 apples. Now, if we take the difference between 72, well, 7 times 2, sorry, it's not 72, it's 84. I'm not mistaken. If we take the difference between 84 and 48, so if we have 84 minus 48, we can see that the difference between them is 36, which means that this answer is going to be correct. Okay, that was number 6. Let's go by number 7. This is a real simple one. It says the price of a 90-meter square flat in London is this price. Find the price rate. So this is very important. This is telling me how much is every meter square. Okay, so if we are wondering how much is every meter square, because it says pounds over meter square, this is saying, my dear student, this is how much money in pounds is 1 meter square of the apartment. This is here. This is what it's trying to say here. Well, it's not an apartment, it's a flat. So what we are going to do, we are going to take the full price, 432,000. And we are going to divide it by all the meters squares we have, 90. So we take the calculator. 432,000 divided by 9. 4,800 pounds. So it's going to be 4,800 pounds for every meter square. It's a little bit expensive, but keep in mind that we are living in London, right? Okay, now for this one, this is an additional for you to practice speed. So, voila. We're going to practice this. It says an athlete run 100 meters in 10 seconds. He covered 32 meters in the first 4 seconds. Find the average speed. Okay, so here we have to remember two things. Speed, what we call velocity. Well, this is going to be the symbol of a speed. I'm trying you to get used to this symbol because speed is usually symbolized with v. Is the distance over time. Now, this formula we saw it in class. Is even in the presentation. Well, let me find it out here. Speed is the distance taken, well, the distance traveled over the time taken. So that is the formula. Well, I can put it here if you want, for you to have it in your eye. Now, if we want to solve this, we can say that we have distance and we have time. So let's see, during the first 4 seconds, okay, this is A, we are going to look for the speed. Now, the time we have it's 4 seconds. But what is the distance in the first 4 seconds? Here it says he covered 32 meters in the first 4 seconds. So we are going to write 32 meters. 32 divided by 4, 8, as you know, meters per second. Okay, this is A, which is that. Now let's go by B. B says that we need to find the speed during the last 6 seconds. So we have time 6 seconds, but we don't know the distance traveled. Now remember that if this is 100 meters, 100 meters, and it says that in the first 4 seconds, this is the first 4 seconds, what was the distance that it covered? 32 meters. 32 meters. Now, this last part is 6 seconds because we know that is 10 seconds, right? So the total we know is 10 seconds. So what is going to be the distance here? Easy peasy. 100, we subtract 32. 100 minus 32. That is going to give me, I don't know. Sometimes I have to check. 100 minus 32. 68. 68 meters. So 68 meters is going to be the distance that was traveled in the last 6 seconds. We divide this by 6, and it's going to give me 11.3. Okay, 11.3, well, 33 maybe meters per second. Then the last question, it says for the entire race. The entire race, the speed is really easy to do because the total time of the race was 10 seconds and the total distance is just 100 meters. So if we do math here, it's really simple. To do that, we have to divide 100 divided by 10, which is just 10 meters per second. With that said, we finish everything. I'm going to send you, of course, the paper for you to practice. I hope you will study. That's the main thing for you to do. You to learn. So, with nothing else to say, bye bye. Thank you for watching.